So here's another way that the chain rule shows up. If I want to take the derivative of a function with respect to a variable that isn't in the function, I can use the chain rule to do this. So you see what the way this is written up here, the top right of your page. If I want to find the derivative of y with respect to x, but y isn't a function of x, y is a function of some other variable, in this case u, I can find the derivative of y with respect to x by finding the derivative of y with respect to u and multiplying by the derivative of the function u with respect to x. So here's an example. What if I have a function y is equal to 2u? So whatever u is, multiplied by 2, and that's what y is. And I know also that u happens to equal 3. I could write y as a function of x. So I know y equals 2u, but I know what u equals. I know y equals 2 times, instead of u I can write 3x minus 5, and I have a new function, y is 6x minus 10. So that's one way I could do this. I won't always be able to do this. This just happens to work here. Could I now find dy dx? Sure. If y is equal to 6x minus 10, then dy dx is just 6. And notice I'm taking the derivative of y with respect to x, and x is in fact a variable in this function. So what if I couldn't make that substitution, or it was hard to make that substitution? I could use the chain rule instead. So I'm going to find dy dx by using the chain rule, and I'm going to prove that it's equal to the answer I got when I was able to make the substitution. So dy du, if y equals 2u, well, what's the derivative of 2 times x would be 2. So what's the derivative with respect to u of 2 times u? That's just equal to 2. And what's the derivative with respect to x of du, of u? So u is 3x minus 5, du is just going to equal 3. And you can just notice this one example where you can do the chain rule, or we could do it sort of the long way, and is dy dx equal to dy du times du dx. Yeah, because we got 6 here, and that's equal to 2 times 3. So all of these problems on the back, we could use this second version of the chain rule just as easily if you wanted to rewrite these functions as a function of u, and then u is a function of x. So just for an example, again, either way is fine on this, so I'm just doing this as an example. Here, f of x is the cube root of sine x. So I'm going to think of this as f of x is the cube root of u, and u equals sine of x. So now I have y is the cube root of u, and u is sine x. Can I find dy dx? Dy dx is going to equal dy du times du dx, which is the derivative with respect to u of the cube root of u is 1/3 u to the 1/3 take away 1 negative 2/3 times du dx, so u is sine of x, du dx is going to equal cosine of x. And then just notice we've been asked to give dy dx, or f prime of x. The only variable I'm expecting in my answer is an x, so I would just come back through and replace u here with this expression for u. So my final answer would be 1/3 sine of x to the negative 2/3 times cosine of x.